All right, good morning, class. So today we are going to be covering chapter section 3.1 of our textbook. And so our main goal with this section is to cover product rule and quotient rule. These are both two very big concepts. You're going to be using them over and over again for the rest of this class. So you definitely want to make sure you get this stuff, get a good hold, get a good hold of it so that you can use it properly when we start applying this to more complicated equations. So this is good stuff. Definitely remember this. You're going to need this later in this course. Let's go ahead and get started. So I'll also go ahead and warn you, because in this section for 3.1, we're really just covering these two rules, the product rule and quotient rule. We don't have as much material to cover. So I'm also going to take the time during this lecture to kind of give you a little proof for why these rules are true and why they work. This is not material you're going to be tested on, so you don't have to write that down or remember it. But if by chance you're curious about, well, why is this true? Where did this come from? How do we know this works? Then I'm going to show you that today during the video as I present these rules. So, first up, we're going to talk about the product rule. And of course, at the end, we'll do a few examples, just so that you can see how this stuff works in practice. So, what is the product rule? Well, first, let's have a T there instead of an F. Let f of x and g of x be differentiable functions. And suppose y equals f of x times g of x. Now this is why we call this the product rule. Anytime we're dealing with an equation that is some function of x times another function of x, this rule is going to come into play when we want to find our derivative. So what is the rule? Well, we say that y prime, or in other words, the derivative of y with respect to x, dy dx, is equal to the derivative of the first guy, so that's f prime, times g of x with no derivative, just regular old g of x, plus f of x, this time with no derivative, times g prime of x, the derivative of the second guy. And that's it. This is the product rule. This is the derivative when you have a function times another function. So really, it's not so bad to memorize. Just remember that it's the derivative of the first times the second plus the first guy times the derivative of the second. You're going to take the derivative of both of them, multiply them against the other without the derivative, add them together, and that's it. It's not too complicated. But why is that true? Where does this come from? Because without really talking about it, this kind of seems to just come out of nowhere, right? Well, let's actually look at this for a second. So, to be able to get to this equation here for the derivative, we're going to use the limit definition for the derivative of a function. So recall that if we have f of x, then f prime of x is equal to the limit, as h goes to 0, of f of x plus h minus f of x divided by h. This is the definition for the derivative using the limit definition. We're going to use this definition to be able to force it to turn into this guy. And once we know that that's what the derivative is for a function times a function, then you'll never again have to use this definition whenever you're dealing with these guys. So it's a nice shortcut. That's why we have the product rule. But before we actually use it, I want to take a chance to show you why it's true so you can understand that, and then we'll move forward with some examples and such. So, product rule. And again, you're not going to be tested for this proof I'm about to write. It's just for your own benefit to prove to yourself that, hey, this really does make sense. So, without further ado, let's go ahead and do this. So, y prime, which is equal to dy dx, is equal to the limit as h goes to 0. Now, the first step, we just take x plus h and plug it in for the function. So that's what we're going to do here, except we have two functions. So we're going to have f of x plus h times g of x plus h, and then minus the function when we just plug in x. So that's just f of x times g of x, and then divide by h. So far, nothing tricky. All we've done is just plug in based on this definition using what our function is. All right, so now what? Well, from here, we can kind of cheat a little bit because we already know we're trying to get to f prime times g and f times g prime. So what does that mean? Well, remember from our limit definition up here, we have f prime is equal to f of x plus h minus f of x. Well, we have an f of x plus h, but we'd like to isolate it so that we can get a minus f of x on it, and so that they're by themselves to have f prime. Well, we don't have that yet, but here's what we can do. So we have the limit as h goes to 0, f of x plus h times g of x plus h. Right now I'm just recopying what we have. Now here's where I'm going to do something different. I'm going to, here in the middle, between these two terms up here, I'm going to subtract f of x g of x plus h. Now why am I doing this? I'm doing this because with this minus f of x g of x plus h, this other term has a g of x plus h, and so if I factor this g of x of h out, then I'm going to be left with f of x plus h minus f of x. This is good. This is what I want in order to get f prime. But the catch is, if I choose to just magically subtract this, then I also have to add the same term back. Why? Well, that's because you can't just add and subtract willy-nilly. But what I'm really doing here, I'm subtracting f of x g of x plus h and then adding back the same f of x g of x plus h. In other words, this is the same thing as doing minus 1 plus 1. What's minus 1 plus 1? Well, that's really just 0. So what have I actually done here? All I've really done is I've just added 0 to my equation. You can add 0 to your equation all day without changing it at all. So that's the trick I'm using here. This is, I guess you could think of it as a fancy 0. As long as I subtract and add the same term in the middle, then I've not really changed the equation, but this allows me to create these extra terms so I can factor out g of x plus h. Now the beautiful thing about this is, now on the right side when we write our last term, which was still from above, minus f of x g of x, and I apologize, we're bleeding over into the definition over here. Now I have this new numerator, and this whole thing is divided by h. Okay, so far so good, so why do we care? Well, from here, we're already halfway there. So like I discussed, here in this first part, I can factor out a g of x plus h. So what do I have? I have f of x plus h minus f of x, factor out a g of x plus h, and I'm going to go ahead and, because I have this divided by h, I can divide the numerator by h in different parts and just separate them by a plus or minus sign depending on what's up here. And then that way it's going to help me break this apart. So this is divided by h. So that covers this guy and this guy. I still need to cover these two terms here on the left. Well, remember that the formula also calls for g prime. Well, lucky for us, for this middle term that I created here, if I factor out an f of x on the left, then I'm going to have a g of x plus h minus g of x. This is good. This is what we want here. So we've got plus, and if I factor out the f of x on the right side, then I'm going to be left with g of x plus h minus g of x. And then this whole guy is divided by h. Okay, so far so good. Now what? Well, anytime we're dealing with fractions, I can pull this numerator off and just leave it on the side because it's multiplying. Just like if I have 3 times 2 divided by 4, that's the same thing as 3/4 times 2. We're just applying the same principle to here. So, and also remember that when we have the limit of something plus something, I can distribute that limit. So we're also going to do that. So here I've got the limit as h goes to 0 of f of x plus h minus f of x divided by h times g of x plus h plus the limit as h goes to 0 for f of x times g of x plus h minus g of x all divided by h. Okay, so far so good. Well, what do we have now? Well, when we have the limit of something times something, then we know that we can also still distribute the limit again. So what's the limit of f of x plus h minus f of x divided by h? That's just the definition for f prime. So that's beautiful. That's what we want right there. That is f prime of x. Now over here, when we take the limit as h goes to 0, h equals 0 then. So g of x plus h, what is that really? That's just g of x. Okay, great. So we got our plus sign here. Now the limit of f of x as h goes to 0, well, there's no h to plug in. It's just an f of x all by itself. So that's just f of x. And then lastly, we have the limit of g of x plus h minus g of x divided by h. But what is that? Again, that's the definition of the derivative. This is just g prime. And we're done. And so using the limit definition for the derivative, we can work through kind of the ugly math here to get to the product rule. F prime of x times g of x plus f of x times g prime. And that's it. So it's really a very nice rule. And now that we know this rule, whenever you have a function times a function, you can save yourself the trouble of having to use the limit definition and just go straight to taking your derivatives and adding them together over here using the product rule. So this is great. But let's see some examples in action for how the product rule works. And then we'll talk about the quotient rule. And again, all of this in black here, you're not going to be expected to remember that. That was purely for your own benefit to see and to maybe better convince yourself that this product rule is not just nonsense coming from nowhere. So, there we have it. Let's see some examples. So why do we care about this? Well, let's suppose we have a function f of x is equal to x cubed minus x squared plus 2x minus 3 in parentheses, and then times, let's say, x plus 1. Now, as it currently stands, without using the product rule, excuse me, without using the product rule, the only other way we could solve this would be if we were to multiply this all out. But you can quite clearly see that that's going to get pretty messy pretty fast, because then you got to multiply x times this, times this, times this, and you got to multiply 1 times that, times that, times that, add it all together. There's a lot of moving pieces you got to keep track of. You got to add them correctly. And as you saw in the last video, especially when you're multiplying these larger things against each other, it's very easy to lose some coefficients somewhere, and then your whole answer is going to be thrown off and it's going to be wrong. So, to save ourselves the trouble of having to multiply this all out, now we can use the product rule. Why? Well, one way to look at this is that this left guy in parentheses is just a function of x. Think of it as g. And here on the right, this is just another function of x. Think of it as h of x. All right, so what does the product rule say? Product rule says this is g prime of x times h of x plus g of x times h prime of x. So this is just a straight copy of the product rule there. So now we just plug and chug and figure it out. So what is g prime? Well, we're just worrying about this part for now. And this we can do using power rule and our sum and difference rule. We can take the derivative of each individual part one at a time and just remember to subtract or add them back together in the end. So what's the derivative of x cubed? Well, that's going to be 3x squared, and then we're going to have minus 2x plus 2. The derivative of negative 3 is just 0, so it goes away. That's g prime. What's h of x? Well, we just copy h of x. Here's x plus 1. Plus g of x. So now I just copy g of x. So that's x cubed minus x squared plus 2x minus 3 times h prime. Well, what's the derivative of h? Looking at this guy here now. The derivative of x is 1 plus the derivative of 0, or the derivative of 1 is 0. So the derivative here is just 1, so times 1. And we don't need to worry about that. So there we have it. This is f prime of x. And you're done. There's our derivative. We didn't have to do any messy multiplication. We just took our derivatives, wrote them out, and then that's it. There's our new derivative for f. So it's very clean, very simple, very quick, and this is going to save you a lot of headache. Now in terms of your final answer, yes, you could, if you wanted to, you could multiply these two together, get some new terms, combine them with these, maybe some would cancel out or subtract or whatever. That's entirely possible. In all honesty, that's kind of more work than it's worth, and this is a perfectly valid answer. I would consider this to be a simplified answer. So don't sweat the details of how to write your final answer. As long as you apply these rules correctly, you're going to have something that works, and it's going to get you to the correct final answer. So there you have it. This is the product rule. There are some other examples we can talk about, but we'll get there once we've talked about the quotient rule some. All right. Now, let's see. For the sake of space, I'm going to write our product rule up here in the corner so we can remember it. And then I'll erase what we have there on the left to make some more room. So this is when the product rule is for when y equals f of x times g of x. When this happens, y prime is f prime times g plus f times g prime. And that's our product rule. So star this, remember that, save it away. Okay, now we've got the product rule out of the way. Now that we've got the product rule out of the way, I would like to find my coffee. It's over here. Okay, nice. All right. So, quotient rule. What is the quotient rule? Quotient rule. So as the name would imply, if the product rule was about when we multiply functions, the quotient rule is about when we divide functions. So if f of x and g of x are differentiable functions, then if y equals f of x divided by g of x, then y prime, which is the derivative of y with respect to x, dy dx, is equal to the derivative of the top, f prime of x, times the derivative of the bottom, times the bottom, sorry. So we have f prime times g of x so far. Then we're going to do minus f of x times g prime of x, all divided by g of x squared. And let me fix that 2. That might be a little hard to read. 2. G of x squared. So at first glance, the numerator here is kind of similar to our product rule, right? We take the derivative of the first times the second, and then we subtract the derivative, then we subtract the first times the derivative of the second. Now, keep in mind here, because this is a negative here in the middle, the order here does matter. In the product rule, it doesn't really matter how you do this. You could do the derivative of g times f first, plus derivative f times g. Because of this plus, you can flip these around and you're going to get the same answer regardless. But here we have a minus. And so you have to be very careful when you plug this in to make sure you plug it in correctly. And this is because, if you think about it, 1 minus 2, this is not the same thing as 2 minus 1, right? Over here we get negative 1, over here we get positive 1. Clearly, that's not equal. So be very careful of that. Make sure that for this numerator, when you're using the quotient rule, you do the derivative of the top divided by the bottom minus the top times the derivative of the bottom divided by the bottom squared. Sometimes people will write this quotient rule as t prime, t for top. So it's top prime bottom minus top bottom prime divided by bottom squared. Whichever way you prefer, I don't mind if you write it like this. That's okay. Either way, I just want to make sure that you remember this quotient rule correctly and you keep track of the top and bottom functions separately and plug them into the correct position. This is very important, otherwise it's going to mess up your derivative. Alright, so there's the quotient rule. Now, again, just as for the product rule, why does this work? Why is this true? Well, again, we can get this from the limit definition for the derivative. So I'll write that up here again. F of x is equal to the limit, as h goes to 0, of f of x plus h minus f of x, all divided by h. So this is the definition for f prime, the derivative of f. We're going to use this definition, apply it here, and be able to get it to come out like this. And you'll see how this works here. So let's just work through it. So y prime is equal to the limit as h goes to 0. And just as before, I'm just going to take f of x divided by g of x and just plug in x plus h. So I'm going to have f of x plus h divided by g of x plus h minus, and then what I get when I just plug in f, or when I just plug in x, sorry, we have f of x divided by g of x, all divided by h. Okay, so far nothing fancy. The first step we'd like to do here is clean up this numerator. You see that we've got fractions within fractions. That makes things a little more difficult. It's more work to work through. So in order to simplify this, I'm going to multiply the numerator by g of x plus h times g of x. But if I do that to the numerator, I have to do the same thing on the denominator. And that's because if you multiply by a number that's the same in the numerator and denominator, well, think about it. What's a divided by a? That's just 1. So what am I doing? I'm really just multiplying this by 1. And I can multiply an equation by 1 all day long, and it's not going to change anything. So that's why this works here. So we've got g of x plus h times g. Now why did I choose that? Well, when I multiply this guy across the numerator, it's going to cancel with the denominators of these fractions in the numerator. So this is nice. This is what we want here. So we're going to have the limit as h goes to 0. So this first guy, g of x plus h times g of x plus h in the denominator, they're going to cancel, and I'm going to be left with g of x times this guy on the left. So I've got f of x plus h times g of x. So far, so good. Minus, the same thing happens here on the right, except the g of x cancels. So now I'm going to have f of x times g of x plus h, all divided by h times g of x plus h times g of x. All right, now what? Well, just as before, we can kind of cheat a little bit, and we know we want to get an f prime up here in the numerator. Well, we have f of x plus h, but I'd like to be able to get it alone so that I can have f of x plus h minus f of x. So if I use the same trick here, if here in the middle I subtract f of x and then I tag on a g of x, then I'll be able to factor out the g of x, and I'll have f of x plus h minus f of x. So this is the same trick we're going to use as before. But if I subtract that, I also need to add it back. So this is the same thing as adding 0, and so I've not really changed anything by doing this. So this is great. This is what we want here. So I'm going to put this in the middle, just as before. So we've got the limit as h goes to 0. Now, I'm going to go ahead and pull this denominator of the g of x plus h times g of x off to the side, which is perfectly fine. I can do that. If I have, say, 1 divided by 3 times 2, that's the same as 1/3 times 1/2. So I can pull denominators apart like that as long as I keep this guy in a denominator. So I'm going to use the same thing. So I'm going to have 1 divided by g of x plus h times g of x times, and I'm going to add this middle term. Now when I add this middle term, I can already see that, let me use a different color here, that when I look at this guy and this guy, I can factor out a g of x. So I'm going to do that, and I'll be left with f of x plus h minus f of x times g of x, right? And then same thing for the right guy. I'm going to factor out the f of x to the left side and make sure we keep this negative here in the middle. So I've got minus f of x times And when I factor out the f of x, I'm going to be left with g of x plus h plus, since I've got a plus over here, g of x. And this is all divided by h. Now let me just double check here, make sure I'm still following along correctly. Yeah, f of x plus h minus f. Yeah. Let me just double check what we got here, make sure that I'm happy with what we have so far. Okay, and I'm back. So yeah, there was a slight little mistake I made. This negative here goes along with the f of x, g of x plus h. So when I factor out the f of x, I forgot to have this negative here on g of x plus h. And so this negative went with that. This plus actually comes from here since we put these guys in the middle. So that's what I get for trying to skip some steps. I should have plugged this in before trying to factor it out, but it's all going to work out in the end. I'm also not going to be expecting you guys to remember this. This is just for your benefit to see that this really does work. So this negative I had in the middle, that should actually be a plus. This g of x plus h, this should be a negative because of this negative sign. And then we would have a plus g of x over here because it was positive there. All right, so good so far. So what do we have here? Well, just as before, if I have the limit of something times something, I can distribute the limit and take the limit of each part separately. So what's the limit of 1 over g of x plus h times g of x? Well, h is going to 0, so what I really have is g of x times g of x. Well, what is that? That's just g of x squared. Well, this is great. This is starting to look like what we want over here. So let's keep going. Now, if I look here on the right side, and if I divide this h into both of these numerators separately, because I got this plus sign, I can do that. If I divide this left side, then f of x plus h minus f of x divided by h, well, that's just the definition for f prime. So there we go. There's f prime of x. And then we still got this g of x tagged on, since we factored it out. Now over here, notice we have a negative g of x plus h plus g of x. That doesn't quite match up with our formula. We need g of x plus h minus g of x. We got the negative and positive flipped. How do we fix that? Well, if I distribute out a negative 1, so this middle sign is going to change to a negative, then this will become g of x plus h. It'll become positive minus g of x. It'll flip the signs on the inside. By flipping the signs, that's going to give me what I want for the limit definition of the derivative. And so this f of x will still sit out here on the left side. And then I'll have g prime of x. So this is great. This is exactly what I have for the numerator of the quotient rule. F prime of x, g of x minus f of x, g prime of x. And then we divide it by g of x squared, and we're golden. There's our quotient rule. So there you have it. There's where the quotient rule comes from. You can get it directly from using the limit definition for a derivative. The whole point of me showing you this is that this is where the product rule comes from, and that now that you know it, you can see that if we were to go this route with finding derivatives for a function divided by a function, then it's going to be a headache and it's going to be a lot of work. So to save ourselves the trouble, we now know that this rule works in general for any f of x divided by g of x, and so we can go straight to using the rule without going through all this mess with the limit definition. Alright, cool. So how does this work in practice? Well, let's take a look. Let's take a look. Alright, so for this first example, consider when f of x is equal to, let's say, let's go with this guy. X plus 2 divided by x minus 1. This is an example that we keep bringing up over and over and over again when we've been working through these examples. Alright, and I'm back. Had to pause for a moment. Right, so what are we doing? We are working on the quotient rule with this example. Now this is an example that we've been seeing over and over again in this class because, quite frankly, it's just good for a lot of stuff. So we had a vertical asymptote here at 1, but then we also had a horizontal asymptote at y equals 1. The powers are the same, so you look at the coefficients, and that's where we know the horizontal asymptote is. And this function looked something like this. But maybe I want a function that's going to tell me what is the slope at any given point on this graph. That's when we need the derivative. But in this case, just as before, there's not really any way to simplify this. We can't break this fraction down. So our only option is to apply the quotient rule. So how do we do this? Well, following the formula, f prime, we want the derivative of the top. Well, lucky for us, that's just 1, times the bottom, x minus 1, minus the top, that's x plus 2, times the derivative of the bottom, that's 1 again, all divided by the bottom squared. Alright, and there we have it. Now let me go ahead and warn you, because this is a mistake a lot of students made. Do not be tempted to go ahead and divide out these x minus 1's here. You cannot do that. You can only cancel like that if they are being multiplied against each other, not when it's a plus or minus. Why? Well, think about it. If we go to regular numbers, if I have 2 times 3 divided by 2, then yes, I can cancel that. That's just 3. That's because multiplication and division are the inverses of each other. They cancel each other. That's why 2 can divide out. But if I take those exact same numbers, and I have 2 minus 3 divided by 2, you cannot cancel out the 2's there. If you do, then you would be saying the answer is negative 3. But is it really? Well, 2 minus 3 is negative 1, so that's actually a negative half, which is not negative 3. So don't do that. Same thing being up here. Even though there's an x minus 1 here, and there's an x minus 1 here, because they're being subtracted here in the middle, you can't just divide them out like that. You can't do that. So be careful of that. Make sure you don't make that mistake. You will get it wrong and you will lose points for that. So what else can we do? Well, we can finish multiplying this out, and we're going to have x minus 1 minus x plus 2 in parentheses here, divided by x minus 1. Now I could distribute the negative here, then try to combine these guys in the top. And so I've got x minus 1, I distribute the negative, minus x minus 2, divided by x minus 1. So the x's are going to cancel. Negative 1 minus 2 is negative 3, divided by x minus 1. And that's our derivative. This is going to tell us what the slope is at any given point. So this is great. This allows us to get to the derivative quite quickly using the quotient rule without having to apply the limit definition for the derivative. So we like this. Notice we also have some interesting things going on here. If we look at our derivative, what's the derivative at x equals 1? Well, if I try to plug in 1, I'm going to get a 0 in the denominator, and I can't do that. Well, let's think about it. Looking back at our graph, the question is, what is the slope at x equals 1? Well, there is no slope there. Or more correctly, from the left side, it's infinitely increasing, and so it has a positive infinity slope. And from the right side, it's infinitely decreasing, and so it has a negative infinity slope. From the left and right, we're getting a positive infinity and negative infinity. Clearly, that's not the same number, and so the derivative does not exist at x equals 1. So this is neat. This is using our information based on discontinuity and such. And there you have it. There's our quotient rule. Let's see. I wanted to go ahead and end a little bit earlier today. The last thing I would want to warn you guys about is that it is possible to have a problem where you have to combine the quotient rule and product rule. Well, what do I mean by that? Well, suppose you have a function that's something like f of x is equal to x cubed plus x squared minus x plus 3 times x plus 2, all divided by, let's say, x plus 3. Well, in this case, I mean, clearly it's a fraction. We have a function divided by a function. So we would apply quotient rule. But what's the derivative of this top? The derivative of the top is a function times a function. How do we get the derivative of a function times a function? You use the product rule. So this is something where you're going to have to use the product rule and the quotient rule. Make sure you know how to do these kind of questions. And of course, we can talk about this specifically during the Q&A. But I wanted to go ahead and end the video a little bit early since I know my first few videos ran long. And so I wanted to cut them a little bit shorter today. So with that being said, there you have it. There is the product rule and quotient rule. Make sure you know them, understand them, practice them a little bit. Of course, you can let me know if you have any questions, concerns, email me, and we'll talk about it. Otherwise, that's all I have for you today, so best of luck.